Okay, so you should be on page 175. We're going to take a look at a different look at parabolas from what we've looked at in the past. In the past, we've looked at parabolas like y equals x squared. What's going to change is the equation that we're using. So y equals x squared. It's our normal parabola, and then we could put different multipliers in the front. Remember, if we graphed something like y equals 2x squared, this point, which would normally be at 1, 1, would stretch vertically to 1, 2, and so that would give us a steeper parabola. And so instead of negative 1, 1, also we'd have negative 1, 2, and so it's a taller, skinnier parabola if you put a multiplier in front. Okay, so that's what we looked at before, but now we're going to take a different look at parabolas. Before we said that a parabola was just anything that had a second degree variable in it, and that's still true, but the actual definition for a parabola is that it's a set of points that are equidistant from a line and a point. And so let's say we take, go ahead and sketch this with me. So if you draw a set of axes like that, and then let's graph a horizontal line at, let's say, y equals 2. Okay, so I'm going to do a dotted horizontal line. Okay, and then 4 units above that at y equals 6, I'm going to put a point. Okay. Now, it says the definition of a parabola is a set of all points that are equidistant from that red line and the red point. And so one possible point on our parabola would be this point right here. It's 2 units away from the line, and it's 2 units away from the point. So that's 2, and that's 2. But we can move around left and right as long as we stay the same distance away. So for example, if I pick a point about right there, wouldn't you say that that distance and that distance are about the same? Or you can adjust it if they don't look the same on yours. I'm going to adjust mine just a little bit to maybe right about there. That distance and that distance now look the same to me. And then move further to the right, and is that distance and that distance about the same? Okay, and then do the same thing going to the left. That distance and that distance. And then that distance and that distance are the same. And so if I do that for all the possible points in the plane, then I get this parabola. So we still get a parabola, but it's just a different definition than we've ever looked at before. So the definition is in your book right here. A parabola is defined as a set of points equidistant from a line. The line is called the directrix. So in this graph that we created here, this red line, the dotted line, is called the directrix. And then the point that we kept equidistant from is called the focus. Okay, so we have a focus and a directrix. All the parabolas that we've graphed in the past had a focus and a directrix. We just didn't focus, and no pun intended, on that attribute of the graphs. And so the reason why we're looking at that now is because there are lots of applications, especially with the focus. The directrix isn't necessarily something that we do anything with, but the focus is very useful in science. If you imagine, you've probably seen, satellite dishes have gotten a lot smaller, but you have probably driven by like airports and broadcasting studios and things like that, where you see a big giant satellite dish like this on the top of the roof. Have you seen something like that? Okay, well, this cone right here is the receiver of that satellite. dish. And so they make the dish in the shape of a parabola, and by putting the receiver right there at the focus of the parabola, that allows the reception to be the best. So when we have satellites traveling through space and they're sending their signal to the satellite dish, all the signals are going to bounce right back toward that focus. And so when the satellite's over here, it's going to bounce back toward the focus like that. And so by putting the receiver right at the exact location of the focus of the parabola, allows it to receive all of the data from that satellite until, obviously, if it gets way over here, it's not going to be able to receive a signal anymore. But by making that satellite dish in the shape of a parabola, it allows it to receive a good, strong signal for satellites in a very large span of space. Okay, so that's one application. Similar idea, if you've ever watched NFL or college football games, once in a while you see a guy standing on the sideline, not necessarily a guy, but a person standing on the sidelines with this big, have you seen the big clear dish? They stand there and they're holding, looks kind of like a gun, and they're holding on to that, but it's a big clear dish, and they're pointing it out at the football players. Have you seen raise your hand if you've seen that before? A few people, okay. If you watch football on TV, you'll see that once in a while. So they'll be standing there holding on to this big, what looks like a big glass dome, and they're pointing it out at the football field. That is it's a microphone that will receive sound from whatever they're pointing it at. And so when you're listening to the football game on the TV, sometimes you can hear the quarterback really loud and clear, even though there's a lot of noise from the crowd, the fans, and all that. You hear the quarterback clear as day calling out his cadence to snap the football, and barking out orders at the players and things like that. And so the reason why is because this is a directional microphone, and by pointing, so there's also a receiver right at the focus of that parabola. It's probably actually inside. It's probably like right there. And that's why it doesn't receive any sound from the fans. The fans are back here behind the person with the microphone, and so none of those sounds are getting into the microphone. But the quarterback, who's out here in the middle of the field, his voice is coming right into that microphone, and so it receives only the sounds that are coming from that very specific location. So if he can point his microphone right at the quarterback, he's going to hear the quarterback, and he's not going to hear all the other background noise that's going on. And so that's another application of parabolas, is that by putting the tip of the microphone right at the focus of the parabola, he's able to hear, or the microphone was able to receive that specific sound that he's looking for. Okay? So that's the reason why we're looking at a different form for the parabola. If you skip down to page 176, it shows you all you really need in this table is this part. The rest of it will come from the graph, so you don't need to really pay any attention to the rest of that stuff. So we've changed the form of our equations, so now we are solving for x squared or y squared. So when we say a vertical parabola, vertical meaning it goes up or it goes down. So a parabola that goes up would have the equation x squared equals 4py, and a parabola that goes sideways would have an equation like y squared equals 4px. And so notice that we could change this to the old form if we wanted. That would be, if we solved for y, that would be y equals 1 over 4p x squared. So this 1 over 4p is the same as what we used to call a. Okay, remember back what I was talking about earlier? There's a equals 2. Well, now a would be 1 over 4p. So we're just using a different set of parameters, and we're writing the equation differently. But the reason why we write it this way is because this distance p is the distance from the vertex to the focus. So if this is the focal point, this distance will be p. And the directrix is also p units away, so this distance will be p. And on this parabola, same idea. The focus is there, this distance is p, and the directrix would also be a distance of p units away from the vertex of the parabola. Okay? So when p is positive, it opens in the positive direction. When p is negative, it would flip the other way. So if p was negative, so this is p being positive. If p was negative, we'd have a parabola that goes like this. P is less than 0 in that case. Or for the sideways parabola, this would be p is negative. So this one is p is positive, and if p is negative, then it's going to open in the negative direction. Okay? And so we'll do a couple examples using that. But the key is that p is the distance from the vertex to the focus and the distance from the vertex to the directrix. Any questions so far? Okay, so they have one example worked out for us here. So they're giving us the focus and the directrix. So they're giving us this point, which is the focus at negative 8, 0. And then the directrix is this line right here at x equals 8. And so we know that the vertex has to be halfway in between those. And we also know that the parabola has to wrap around its focus. It's always going to go away from the directrix and wrap around its focus. And we can tell now that p equals either 4 or negative 4. Now, since this one opens in the negative direction, p is going to be negative 4. And so since it's a sideways parabola, it's going to be y squared equals 4px. And we can see now that p is negative 4, so y squared would be negative 16x. Or here I'll write it in steps, so it would be 4 times negative 4x, which is y squared equals negative 16x. Wait. Oh, I didn't realize on the graph that they're counting by 2s, so that's actually negative 8, isn't it? 8 and 8, because I didn't see that on the graph. It counts by 2, so 2, 4, 6, 8. P is actually 8, or negative 8, so that's going to change this to negative 32x. Okay, so if we, well, are there questions on example A? We can do example B together as well. Questions? All right, so example B, we're going to go to the focus, 0, negative 2, and plot that point. So 0, negative 2 would be down here. Again, the grid they gave us counts by 2s. And then the directrix is at y equals 2, so that would be up here. And the vertex of our parabola is halfway in between. Okay? And it's always going to wrap around its focus. Now, at this point, we're not really concerned with the shape of the parabola so much. We just want to make sure that it's opening in the right direction. So the parabola always wraps around its focus, and so in this case, it's going to have to go down. And since it's if it's going up or down, we know it's always going to have the form x squared equals 4py. A way that you can remember that is to think back to the very first parabola that you graphed. Y equals x squared went up and down. So anytime you have x squared, you know it's going to go up or down. And in this case, it opens downward. What would p be? Negative 2 is right. So p equals negative 2. So we're going to have x squared equals 4 times negative 2 times y, or x squared equals negative 8y. So that is the equation of this parabola. Remember, if we wanted to convert it back to the old style that we became familiar with when we first started graphing parabolas, we could solve for y, and that would be y equals negative 1/8 x squared. So this is the new format that we're working with now, or the new form for the equation. This is the old form that we used in Algebra 1 and at the beginning of Algebra 2. Okay, so I didn't fill in any of the blanks here, but we basically did all the work over on the side, and we ended up with x squared equals negative 8y. Okay, and now I think you're ready to go ahead and try 3 and 4 at the bottom of 177. So go ahead and work on those for a few minutes, and then I'll check in with you. Okay, let's see how you did. So on the first graph, the focus is at 2, 0, which is here. The directrix is at x equals negative 2, which is a vertical line. And so the vertex of the parabola has to be halfway in between those two, and it's going to wrap around its focal point. And we see now that that p is positive 2, and since it opens sideways, it's going to be a y squared. Y squared equals 4px, so then y squared equals 4 times 2 times x, or y squared equals 8x. Any questions on that one? Okay, and then this one, I don't really like the scale that they gave us since we're working with fractions like 1/2. It doesn't make sense to have our scale by 2s, so I'm actually going to change this to I'm going to call this 1 and 2 and negative 1 and negative 2 and 1 and 2 and negative 1 and negative 2. So you're welcome to change those scales anytime you need to. And so our focus is at 0, negative 1/2, which would be here. Our directrix is at y equals 1/2, which would be like that. And our parabola vertex is halfway between those two and wraps around its focus and goes away from the directrix. And so we see that now that p equals negative 1/2. And so our equation is going to be, since it's an up and down parabola, it's going to be x squared equals 4py. And so that is x squared equals negative 2y. Any questions on that one? Okay, so going on to the next page, we can translate any of these parabolas the same way we have in the past using the parameters h and k. This is no different than transformations that we've done on previous circles and parabolas and absolute value graphs and all those. It's the same thing. If you replace x with x minus h, that's going to shift it in the x direction. So h shifts it horizontal, and k shifts it vertically. And so that's no different than anything we've done in the past. So the equations are the same. We're just shifting them by h and k. So the vertex is now going to be hk. And again, you don't really need any of this other stuff. Don't confuse your brain with so much extra information that's not necessary. If you understood the graphs that we just did, you don't need any of this extra information. You can get it from the graph. Okay? And so now we can graph parabolas that are not that have the vertex somewhere besides the origin. And so for this one, the focus is at 3, 2, so they plotted that point. And then the directrix would be y equals 0, which would be that horizontal line. The vertex is halfway between the two, which is at the vertex right there would be at 3, 1. And since it's an upward parabola, we know it's going to have the form x squared equals 4py, but it's shifted, so it's x minus 3 squared equals 4. P in this case is 1, and y gets replaced with y minus 1. And so our final answer then is x minus 3 squared equals 4 times y minus 1. And it's probably best to leave it like that because you can see the vertex, but that would be the same as 4y minus 4. So those are both correct, but by leaving it this way, we can still see where the vertex is, which is useful. Questions? Okay, and so we'll try another one here. So if we start at the with the focus of -1, -1. Let's see, I'm going to change my scale again. I'm going to make each line equal to 1. Okay, and so our focus is at -1, -1, which is here. And our directrix is at x equals 5, which is here. And so our vertex has to be halfway between that point and the line. So the point meaning the focus, which is at -1, -1. And this is the directrix. Okay, what point is halfway between those? Discuss that as a group right now. What point is halfway between those two? So what's the average of -1 and 5? The average of -1 and 5? 2. Adam, you get 4. Divide by 2, you get 2. And so our vertex is going to be right there at 2, -1. And the parabola wraps around its focus, so it's going to have to bend this way. It always wraps around its focus and goes away from the directrix. And we see now that p equals 2. No, actually p equals 3. -3, because this distance is 3, but it's opening in the negative direction, so it's -3. So p equals -3. And so our equation is going to be, it would fit the form y squared equals 4px, but it's shifted since our vertex is at 2, -1, it's going to be y plus 1 squared equals 4p times x minus h. And so then that is y plus 1 squared equals -12 times x minus 2. And so if you wanted to fill in the blanks here, this would be y plus 1 equals -12 times x minus 2. Okay, go ahead and try number 5 in your groups, and I'll come around and help you. All right, I'm going to change my scale to ones. So each line represents 1 unit. And so 5, negative 1 is down here. And x equals negative 3 is here. And the point that's halfway between them would be the average of 5 and negative 3. That is 1. And so it's going to be that point right there at our vertex is 1, negative 1. And it's useful to write that down because when we go to write our equation, we have those x and y coordinates to look at because that's h and that's k. And since it's going to have to wrap around its focus, it's going to go this way. And we see now that p goes from 1 to 5, so p equals 4. And since it's going sideways, it's going to be a y squared. So y minus k squared equals 4p times x minus h. And now that's where it's useful to be able to look down here at what our h and our k are. So that's y plus 1 squared equals 4 times 4 times x minus h. And so then that's y plus 1 squared equals 16 times x minus 1. Anybody have questions on that one? Now, earlier I was talking about the directional microphones that they use on the football sidelines. There's actually a picture of one on page 181. That's a parabolic microphone. That's a better. That looks better than what I was trying to draw. So that is exactly what they hold on the sidelines when they're trying to get sound from a very specific location. So right up above that, problem number 7, I'm going to do with you right now. And for some reason my equations got cut off by the graph. It's probably okay in your book, but I just rewrote the equations here. And so what we're going to do is we have an equation in standard form, and we want to write it in the new form that we just wrote, which is, since it's a y squared, we're trying to write this in the form y minus k squared equals 4p times x minus h. And so what we're going to have to do is complete the square for y, because y is the only variable that's squared. So y squared minus 4y. I'm going to move everything else to the other side. 12x minus 64 moves to the other side. Okay, and I left a blank there to complete the square, so I'm going to leave a blank over here as well. Graydon, what number do I need to fill in the blanks with to complete the square?
For y?
For
y it would be 4.
Right, negative 2 squared is 4, so I'm going to add 4 to both sides. Now I have y minus 2 squared equals 12x minus 60. And I can write that as y minus 2 squared equals 12 times x minus 5. So have a 10-second conversation. What is P? Discuss in your groups.
What? How do you guys get that?
Oh, Marshall, because the equation is
Okay. Write down, please. Ella, what did your group get for P? 3 is correct because 4P is what's in front of x minus h, and so 4P is 12. And if 4P equals 12, then that means P equals 3. That's correct. Okay, so P equals 3. So now we can graph our parabola. We know the vertex. What would the vertex be, Jack?
2, 5, 5, 2.
5, 2. 5, 2 is right. So they gave us a scale by 2s. So 5, 2 would be there. And P equals 3. Now, is this going to open up, down, left, or right? Claire?
Not open to the right.
That's correct. It will open to the right because y is squared, so we know it's sideways. And since P is positive, it's going to open in the positive direction. So we know it's going to open that way. P is 3, so if we go 3 units that way, that gives us our focus. Our focus would be at 8, 2. And if we move 3 units the other direction, we get our directrix, which would be at x equals 2. Okay, so we completed the square. And we're able to write the equation in the new form where we can see the value of P, and then we're able to graph it. So go ahead and try that same thing on problem number 8. Okay, let's see how you did. So since x is the only variable that's squared, we have to complete the square for x. So it's going to be x squared plus 8x plus blank. We're going to move everything else to the other side. So that's going to make 16y plus 48, and then plus blank. Okay? Marcia, what do we need to complete the square?
16.
That's right. Half of 8 is 4, squared is 16. So we add 16 to both sides. And now this is x plus 4 squared equals 16y plus 64. And that is x plus 4 squared equals 16 times y plus 4. Ethan, what would our vertex be?
-4, -4.
-4. And P, what would P be, Nelson? Huh? 4 is correct. So P is 4. And so now we can plot our vertex at -4, -4. There's our vertex. And this one is going to go up. So it's going to go up like this, which means our focus has to be 4 units this way, which would be at -4, 0. And then our directrix is 4 units the other way, which is down here. Our directrix would be y equals -8.